He, the average heat energy it takes for bonds to be broken, for a single bond to be broken.
Okay, single bond to be broken or releasing when formed. It's absorbed when the single bond is broken or absorbed when formed. When releasing or releasing when formed. Because we have two type of yeah, or two different process. Breaking a bond and reactant, it will absorb the value of bond energy. Forming a bond in the product, it will release the same value. So we can get the follow and get the whole definition. Standard enthalpy formation.
When 1 mole of a compound is formed from its element under standard conditions.
Okay. Some mean bond enthalpies are given below. Use this data to calculate the enthalpy change for the following gas phase reactions between hydrazine N2H4 and hydrogen peroxide. The table show the data for mean bond enthalpies, and this is structure bonds for the equations. Can you calculate with me?
Okay. Do you want me to calculate it and then I send you a photo?
Yes. So you will each single bond, you can calculate the total number and multiply with the value. But we have
Yeah.
here the value expressing in the reactant breaking, it's a breaking bonds. So the process will be endothermic. So you will indicate the value of bond, the positive value here, but you will indicate in the product a negative value to be the summation relation reactant minus a product. Okay. If we have the same type of bond, OH here, for example, and OH here, you will express it here with a positive sign and will indicate it here with a same value but a negative value, because the bond here is breaking down by absorbing heat. هنا البوند it's really formed or forming the bond by releasing heat. So releasing heat, it means its exothermic reaction or exothermic step will be negative, which is mean when breaking OH, we will absorb كذا. When we forming an OH, we will release the same bond energy. Okay. Dana, can you indicate the value?
Yeah, I'm just working it out.
You can join the board لو انت available for you.
I'm on a laptop, so it won't work.
Okay. Four times 388 plus n bond 163 plus
Is the answer minus 789.
Okay, minus delta H minus 789. You can score it and save it to following calculations. Some standard enthalpies of formation are given below. Here you will use two different methods to calculate the change in enthalpy. One of them by calculating the bond energies, and the other one by calculating delta HF, delta H formation between reactant and product. And here we will compare between the two methods. Either it will be difference or not. So the same reaction here, but we will use the other method by difference in delta H formation. هنا state the value of delta H formation for nitrogen. You can notice that it's not including in the table. Can you guess why?
Because it's an element.
Yes, because the element ionization energy in delta H formation equals 0. Use the delta H formation standard values for the table to calculate the enthalpy change for this reaction.
So what would the value of nitrogen be?
It's equal 0. He asked you why it's equal 0. State the value or it equals 0. We stated that all elements have 0 delta H formation because the element's not formed from any substance. It's already naturally existed in the nature. Elements have always 0 delta H formation. Either it exists in the table or not exist, you have to know this information. Okay, O2, 0 delta H for information, N2, magnesium, zinc, Cl2, either its element, it have 0 delta H formation because it is not formed by any reaction. It exists in the nature. It's naturally exists. Okay?
Okay. Can you scroll down a bit, please?
Use the delta H formation values from the table to calculate the enthalpy change for this reaction.
Okay. Uh, 777.
Positive or negative?
Positive.
Positive. Can you notice that's for the same reaction? Here بقى it says, well, asked explain why the value obtained in part B is different from the obtained in part Ci2. Can you conclude why the difference in the value when we depending on different methods here by delta H formation and here in bond energies? What makes
Because this one is exothermic and the second one is endothermic.
so what make the difference? Explain why the value obtained in part is difference. What make the difference?
The heat energy it takes to break the bonds.
Because the value of bonding energy of nitrogen will make the difference between. So the difference here, the bond energy in nitrogen, which is calculated in the first method and not exist for the delta H formation of nitrogen. Nitrogen here, which is make the difference. Can notice that we added the value of bond energy in exothermally. We added it in the step of the exothermic, which is releasing energy. So it makes the total reaction exothermic. But here we not calculated, have no value in delta H formation. State Hatt's law and use it together with the data given in table below to calculate the standard enthalpy change for the following reaction. Hess's law. Do you studied it?
Yes, Hess's law, yes.
How we can solve this question?
Um, do you write like the products at the bottom and then
Yes.
the equation at to the left, and then on the right it's the reactants, or yeah, the reactants.
We have here the standard equation, okay? Thus not reactants or products. This is the delta H formation for those compounds. So we can consider their equations for formations to indicate that or in expressing that. You mean the delta H for equal delta H summation H formation of product minus the delta H for reactant?
Yes.
You mean that? So,
Yes.
okay. How you can indicate?
We use the triangle, the ABC thing.
What is the triangle ABC? What for what?
No, not like that. Like the products at the bottom, and on the right the elements, and then on the left the equation.
So we can indicate it directly without need for that. MgCl2 it's minus 642 plus H2O it is minus 286. So this is the side of the product minus the side of reactant, which is MgO minus 602 plus 2 times minus 92. So directly without needing for something in direct indication. Number of mole times the value. Here we have 1 mole of water, so plotting its value, 1 mole of MgCl2 plotting its value, there are products minus the total of reactant. So the value will be in
I'm calculating it.
yes.
Minus 510.
Okay. Save your answer. Here, number B, in the experiment, an excess of solid magnesium oxide was added to 50 centimeter cubic of 3 mole Demeter minus 3 hydrochloric acid. The initial temperature of solution was 21 Celsius. After reaction, the temperature raises to 53 Celsius. The specific heat capacity of water 4.2 kilojoule kilo minus 1 gram minus 1. Using this information to calculate the enthalpy change of reaction, 1 mole of magnesium oxide with hydrochloric acid. For your calculation, you should assume that's all heat from the reaction used to reach the temperature of 50 grams. Here, a reaction in excess of solid magnesium oxide added to volume and the concentration of hydrochloric acid. So here we will use this triangle. Concentration equal number of mole divided volume Demeter cube. Here, either we have this given, so we will use this triangle for mole calculation. The initial temperature of solution was 21 Celsius, so we have T1 equal 21. After the reaction, T2 equal 53. All this are investigation. I investigate the information to get the method. A specific heat equal 4.2. That which is required. Use the information to calculate the enthalpy change for the reaction on 1 mole of magnesium oxide. So this required MgO plus hydrochloric acid to give MgCl2 plus H2O. For your calculation, you should assume that all heat from reaction is used. How we can calculate that?
Mm. You find the change in temperature and then you use the equation of the PV equals RT and another letter, I'm not sure.
Can you deduce why you gave me the concentration and volume for hydrochloric acid here? Why I given like this
Find the moles.
information to get the number of moles? Because he asked me for a standard enthalpy for this reaction, and the standard enthalpy given by this equation minus QP divided the number of moles. So I will square that. So I will use this equation by using this information. I need here the number of mole which is getting by this information, and also I will need the QP, from which is information I will get the QP by delta T, specific heat, and the mass of the water, right?
Yes.
So here we will use this reaction. This is law. QP equal mass of the water, which is 50, times the specific heat 4.2, times delta T 53 minus 21, giving a QP. I will use this in this equation to indicate the delta H positive, delta H standard. Delta T equal chem 53 minus 21. It will be 32. Then are you calculating?
Yeah.
Mm-hmm.
6,720.
Oh, that's QP. We will use minus QP because it's adverse process, which is absorbed by the water and released by the reaction. So it will be minus QP divided number of mole. Number of mole will be calculated from that. Concentration is the 3 mole diameter cubic. Volume per diameter cubic, it will be 50 divided 1000, 0.050, giving the number of mole. Number of mole will be equal can
0.15.
0.15. So here, the value of QB divided 0.15, giving you use the information that calculate the enthalpy change of the reaction of 1 mole of magnesium.
Minus 44,800.
Okay, here we make a big mistake. You don't notice that. Which is mistake we done?
We didn't convert.
Not convert. Not forget that is information to give the number of mole of hydrochloric acid. And from mole equation, 1 mole of magnesium oxide reacted with 2 mole of hydrochloric acid. And here he used this information to calculate the enthalpy change of reaction of 1 mole of magnesium oxide, not for hydrochloric acid. So you have to get the mole ratio from the equation to get the magnesium oxide number of mole. Either the number of mole of hydrochloric acid is 0.15, so the magnesium oxide will be half the number. This step will change the whole results.
0.075.
0.075 وطبعا the same QB minus QB divided N giving the delta H. Not all, 95% of students will forget this step.
So minus 89,600.
Yes. Okay, here in number 3 question, the table below contains some mean bond enthalpy data. Write an equation for the formation of 1 mole of ammonia from its element. 1 mole of ammonia from its element. This mole of ammonia is that. To get from its element, we will need a
3 nitrogen. So
nitrogen,
3.
one hydrogen. How we can balance without changing the number of mole of ammonia?
So you can't like add the 2 in front of it.
ده 2 يبقى half into 3 divided 2 O2. When we need the single number, you can make this track. Half 2 divide cancel 2 و 2 هنا cancel 2. So we have here 3 hydrogen atom and 1 nitrogen atom only. Use data from the table above to calculate the value of enthalpy formation of ammonia. So here we can calculate with the bond energy, but by using the number of moles, same number of moles.
So half times 944 plus 3/2 times 436. Is that correct?
It's A, and it will indicate half to. We have N triple N. Yeah, we must show the bonds before indication. So we have N triple N times half plus 3 divided to HH. And we have here NH. So you will indicate by the value and multiplying with the number of moles. You cannot indicate without this step because it make a disturbance. You can confuse. Even I will be confused now. I don't make this step. It doesn't matter or doesn't condition use all the bond. You give your access because you will need in lower questions. We'll use the HH, N triple N, and NH. And you not forget the track. We will indicate the value in reactant by positive value and the value of the product by negative value for the same, either for the same bond. Because it's releasing energy here and it's absorbed energy here.
Minus 182.
Okay, you can save the number, the value. Use the following equation and data from the table above to calculate value for CH bond enthalpy in ethane. You can use the previous table all like this. You can take the values and indicate. Maybe you take a screen. Okay.
Yeah.
Okay. Here. What is the number of CH bond here?
Like the CH.
Yes.
There's no CH.
Here, There is no CH?
No, like there's no value for CH.
Okay, what is the idea for this reaction? There is an idea for that. Can you discover it?
Can you find out like the like
He
all
asked you for calculating CH already because he given you the delta H. You asked for calculate the CH itself, expressing it like X. But we don't need to be exact in both of reactant and the product. We not need the variable to be exist in two sides. How we can make this more easy and simple? You can cancel all the CH equal from reactant with the product. Because as we said to you, when you indicate a reactant with a positive sign, you will indicate the same bond in a product with a negative sign. So they will cancel each other. Firstly, we will cancel CH. Here we have 4 CH. 1, 2, 3, 4. Here, 1, 2, 3, 4, 5, 6. So we will cancel 4 from here. We will cancel 4 from here with therefore, and so remaining 2 CH only here. And to consider them like 2x. This is the idea for the question. If you not make that, you like have two variables or two unknown for the two sides. Okay. Can you make it?
I don't understand, like, do you do like, so you calculate all of them, but you don't calculate the CH?
You
So then,
will cancel firstly the CH from equal CH from two sides. If we here have 4 CH, you can cancel 4 CH from the other side opposite because they cancel each other. So you will cancel CH, 4 CH here with another 4 CH here. Remaining 2 CH. We will calculate those values. So we will calculate we have here remaining 2 CH. We will consider them 2x and calculate x as a variable. X is mean, x is CH. So here we will calculate like this, C double bond C plus HH, because we cancel CH here. Here we have remaining C bond, C plus 2x. 2x here meaning 2 CH bond remaining. All that equal delta H minus 136. So there will be negative all. Can you indicate?
yes, I'm doing it now.
Yes. Are you taking unit 2 and 3 or unit 2 only in May, June?
Unit 3 is the practicals.
Okay, which is including rate of chemical reaction, that's why.
In May, June, we're doing paper 1, 2, and 3.
Okay. The reason why I discussed the rate of reaction because it's in Cambridge syllabus, LAS is total all, including not modules like you. So I consider your Cambridge. I consider that firstly.
I'm Edexcel.
Yes, but not as exhaustive, I think, in the group. Okay.
It's negative 742.
Okay, can you negative 742? Are you sure? Are you sure? Oh, maybe like this. Okay, it's relative to. Okay, here let's just transfer to this. Write an equation to complete combustion propanol C3H6O to form carbon dioxide and water.
So C3H6O equals CO2 plus H2O.
Are equal
And then you have to,
without oxygen. You have here all with oxygen firstly. As the reactant,
oh, yes.
yes, carbon dioxide plus H2O. How we can balance carbon dioxide and water vapor?
I'm balancing it now.
Okay.
Is a 4 in front of the oxygen,
Or هنا.
and then 4 in front of the oxygen,
Mhm.
and then 3 in front of carbon dioxide, and then 3 in front of the water.
Yes, here. Yes, excellent. So here in laboratory experiments, 1.45 gram of propanol were burned completely in oxygen. The heat from this combustion was used to raise this temperature 100 gram of water from 293 Kelvin, 0.1 Kelvin to 351.2 Kelvin. Calculate the number of moles of propanol in 145 gram, 1.45 gram.
So is it 1.45 divided by the atomic mass of propanol?
LMR for propanol, yes. البروبانول carbon is
Yeah.
12. الهيدروجين is 1. Oxygen is 16.
So is it C? Oh, it's C3H6O.
Oh, yes, like the propanol. 3 times 12 plus 6 plus 16.
Uh, 0.025.
0.025 number of moles. So you will use this information to complete the equation, the question. Calculate the heat energy required to raise the temperature of 100 gram water from كذا to كذا. The specific heat capacity for water is 4.18. What calculation we will make?
Is it? Wait, I'll do it now.
The equation like this: QP.
285.8.
Yeah, you indicated mass with 100, the specific heat like this, with delta T difference between them. K Kelvin,
Is 58.1.
58.1, just 58.1 only.
Yeah.
So not
And then
hmm,
times by 4.18 times by 100 is 24285.8.
by you not need to change from Kelvin to Celsius.
No.
No, because it's given by Kelvin, so you will use Kelvin normally. Okay. Hence, calculate the value in kilojoule mole minus 1 for the enthalpy combustion of propanol. This QP, which is you calculated the amount of enthalpy absorbed by water. It's the same which is released from the same mass of propanol to combust. The same mass of propanol to combust, number of mole which is calculated, released the QP, which is you calculated. So always delta H standard equal minus QP divided N. It's a sequence of questions. All with this question will get with the same sequence. You will not, you calculate the number of mole, you will calculate the QP, and so will you use this in relation.
So how would I calculate the combustion?
That the delta H change in enthalpy of combustion, because the combustion of propanol releasing this amount of energy, which is absorbed by the water.
Okay.
So by the dividing the number of mole, will giving you each one mole of propanol giving you delta H.
Yeah.
We can making it another way. When one mole, when number of mole like this, I don't remember, 0.015, giving you definite QP. So one mole giving you what? Which is delta H standard. That's the origin of relation. We can plotting it always, delta H standard equal minus QP divided N.
It's minus 971432.
Yes, therefore 1 mole of A of propanol. In similar experiment, the enthalpy combustion of butanol was found to be 1290 kilojoule mole minus 1. A data booklet value for the same reaction equal kaza suggested one reason why the experimental value is very different from the data booklet value. Why always made the practical differ than the data booklet?
Because heat may escape, evaporation or incomplete combustion.
May incomplete combustion, the mainly reasons will be may some heat will escape, not absorbed all the amount of heat by the water, or may some heat absorbed by the flask or the beaker of the container. This data POC value delta H is for butanol like this refers to formation carbon dioxide gas and water. The gases state how would with value differ if it's referred for formation of water in the liquid state. Explain your answer.
I'm not sure on this one.
Because you have to save this information because bond energy different according to the physical state of the matter. When you calculate the delta H combustion by the bonding energy, by indicating the bond energy, it will differ according to the physical state of the matter. When the water is liquid, or the water is gas, or the water is solid, it's have a slightly difference in bonding energy. And so we will define the bond energy at the average amount of energy used or consumed between the three physical states. Average, not a for definite one. So here it's related with the physical state of the water and their bond energy. Okay.
Yeah.
We will join again the last 5 minutes for completing this question. Okay. We can solve the Hess